Homework number 12 is about conic sections, and we are going to, in the homework, we're going to do one of each type of conic sections that we discussed. We're going to do a circle, we are going to do an ellipse, and then finally we're going to do a hyperbola. Question number 1 is a circle, and the reason why you know it's a circle is because x and y are the same. There's no different denominators. When you have different denominators, that means you know you have either an ellipse or a hyperbola. But when you have an x squared plus y squared equals 16, that means that x and y are equal, which means that the directions, the distances in all directions are going to be equal, which essentially means you have a circle. Now, if you had a different center than the origin, there would be something in parentheses. For example, you might have x minus 1 squared. That means that the center is going to be 1 away from the origin on the x-axis. Now over here, there is none. Over here, you just have a plane x and a plane y, which means that the center has to, by definition, be the origin, 0, 0, which is the same thing as the origin. So that we don't have to worry about too much. Now, but the other thing that we are asked to do is to graph the circle. Now, graphing it means that you have to first plot the origin, which we know, the center, which we know as being the origin over here. And then we have to figure out what the radius is. And the radius is c squared, whatever this number, the square root of this number. The radius squared is this number, which means it's the square root of whatever this is. And of course, the square root of 16 is 4. It's actually plus or minus 4, but since it's a distance, you drop the negative number. And the radius, that means, is going to be 4, which means the circle is going to have to pass through 4 in this direction, and 4 in all directions, because the circle is completely equidistant in all directions. So we're going to put points over here, points over here, points over here, points over here, and then we're going to have to craft a circle. And again, you're going to have to forgive my penmanship. This doesn't look like a perfect circle, but it's, I guess, close enough. Here's an example of what it should look like. I just used a website to graph it, by computer so that you don't have to worry about my freehand. This is what a classic x squared plus y squared equals 16 would look like. Notice the radius is 4 in each direction, and the rest of it is a perfect circle. Now let's look at the second one. This is not going to be a circle. It is going to be an ellipse, however. Basically, if the two denominators are different, the numerators are always going to be squared. That's how you know it's going to be really a double parabola. If there's only one of them that was squared, it would be a single parabola. It would be either a u or an upside down u. If it were, or if the x is squared. If the y is squared, it would be a sideways a u, either direction, depending on whether y was negative or positive. If they're both squared, it means it's going to be a conic section, which means it's going to be a circle, or a parabola, or a hyperbola. I'm sorry, excuse me, not or an ellipse, or a hyperbola. And whether this is negative or positive depends on whether it's going to be an ellipse or a hyperbola. This is positive, so therefore it is going to be an ellipse, which is kind of like an oval, an egg-shaped drawing. And the way you figure out the center is by figuring out the negative of whatever's over here. So up here, let's say, for example, you have x minus 2, which means the x value of the center is going to be positive 2. This is negative 2, so you just kind of take the negative value of this and make that into the center. And then on the right side, you've got the y value, which means the negative of negative 1, which is positive 1. So this is going to be the midpoint. I don't want to call it the center. Center is something that's usually referred to when you're talking about a circle, but this is the midpoint of the ellipse. Then you have to figure out what is called the axes. In other words, how far is each point away from the center. First of all, let's plot the center here. Excuse me, our midpoint is going to be at 2, 1, which is over here. Now, how far away are the edges of the ellipse going to be from the midpoint? And the answer is, you look on the x-axis, it is going to be the square root of whatever this number is. And on the y-axis, it's going to be the square root of whatever that number is. So the distance from the center, or the axis along the x-axis, is going to be the square root of 9, which of course is 3. And then the axis, the minor axis, the smaller axis, the one along the y-axis, in this case it's smaller because the denominator is smaller, it could be larger, is the square root of 4, which of course is 2. Which means along the x-axis it's going to be 3 away in each direction. 1 over here, and then 1 over here. And on the y-axis, in other words on the vertical axis, it's going to be 2 away, which means 1 over here and 1 over here. And again, drawing it freehand, it's going to look something like this. And again, I just put it computer done just to show you what it looks like, and it looks, fairly similar to the one that I did. The center being 2, 1, which is right over here, the midpoint. The longer axis being 3, 1, 2, 3, and the shorter axis being 2, 1, 2, and the edges being kind of roundish or oval. The question also asks us for the foci, or the foci. And the way to figure that out is to apply the focus formula. And the focused formula is the square root of the bigger one minus the smaller one, the bigger denominator minus the smaller denominator. So in this case, the focus is the square root of 9 minus 4 equals the square root of 5. Now the square root of 5 is a little bit more than 2. Actually about 2.24, so a little bit less than 2 1/4. So that's away from the center, away from the midpoint. So 1, 2, so this is going to be one focus. Let's make it a different color just to indicate that it's something a little different. So one focus is going to be right around here, and the other focus is going to be right around there. And you can see the underlying lessons for an explanation of what foci are and what their role is. Number 3 is a hyperbola, and the way you know it's a hyperbola is because it has a minus sign in the middle over here. And by the way, it would be a hyperbola even if x and y had no denominators. As long as there's a minus sign over here, it means they're going in opposite directions. You're going to have one thing in one direction and the other part in the other direction. And so the first thing we're going to do is we're going to define all the things just because it's a little more complicated. What is the a? Now the a in this case is the denominator, always is the denominator of the x term, so at the square root of the denominator of the x term. So our a is 3. Our b is the square root of the denominator of the y term, so that's 4. And we can also define h and k. H being the negative value of whatever is next to the x, and k being the negative value of whatever is next to the y. So in this case, h would be negative 4, because this is the opposite of positive 4, and the k would be negative 3. So what are we asked for? We're asked for the center. And now the center is, of course, going to be hk. So our center is easy. Center is whatever the negative value of this and the negative value of that, so it would be negative 4, negative 3. Okay, that's the first part. The vertices, just like we saw last time, the axes, before I called them axes, now they're vertices. Either way, it's the same idea. The vertices are the distance from the center that each line is going to touch. And in an ellipse, it means the furthest distance. In a hyperbola, it's actually the closest distance that it is actually going to apply to. And the distance, well, from the x-axis, the vertices along the x-axis is going to be the square root of 9, which is 3 away from the center. And the vertices on the y-axis is going to be the square root of 16, which is 4 on the y-axis. So if we, well, actually, that would be in an ellipse. In hyperbola, you're only going to have one set of vertices, because it's going to, the ultimate hyperbola is either going to be something like this or something like this, where the 2 points are never going to touch each other. So let's graph the center. The center was negative 4, negative 3, 1, 2, 3, 4, 1, 2, 3. And, as we discussed when doing the material, because of the fact that the x value is first, the centers, or the lines themselves, the vertices, are going to be along the x-axis. And so therefore, if you count the x-axis, it would be 3 away. So the red is the center. I'm going to use the orange for the vertices, and that would be 3 over in this direction. 1, 2, 3. And 3 over in the other direction. So it looks like this one is negative 7, negative 3. And this one over here is negative 1, negative 3. Notice because the x value is first, x can never actually be 0. Because if x were 0, then you cannot subtract something from it and still get 1. This has to be a positive number. Because this has to be a positive number, the x-axis never gets crossed. And again, because it's shifted a little down because the center is different, it means that this can never be crossed. So this hyperbola is going to look something like this and this, two outer facing half circles in opposite directions. It's going to look something like this. And of course, I'm going to graph it a little bit later on and show you what it looks like on the computer. So now we've got the vertices. The equations of the asymptotes, or the asymptotes, would normally be, let me get a different color over here, would normally be y equals b over ax. Now, of course, over here, because of the fact that the center is different, you have to adjust for the fact that the center is different. So instead of just being y, it would be, I guess, y minus k equals plus or minus, I forgot the plus or minus before, plus or minus b over a times x, but instead of x, you'd have to do x minus h. In other words, you would have to simply adjust for wherever the center is. So if you plug these in, you're always going to get two different asymptotes. So let's plug all these in. So we've got y minus, well, minus k would be plus 3 equals plus or minus b over a, which is 4 over 3, times x plus 4, minus negative 4. And then you could simply make each one y equals mx plus b. Let's do a positive and a negative, so let's split them up over here. Let's do the positive on this side. On this side, we'll do y plus 3 equals 4 times x plus 4. And that becomes 4x plus 16. So we'll do y plus 3 equals 4x plus 16. And then subtract 3 from each side. Sorry, I forgot to put this denominator there. So it's actually 4/3 x. So it's actually 16/3. 16/3, subtract 3 from each side. And you get y equals 4/3 x. And then 16/3 minus 9/3 is 7/3. So that would be one equation. And the other one would be the negative value. The other one would be y plus 3 equals negative 4/3 times x plus 4. So you've got y plus 3 equals negative 4/3 x minus 16/3, and again you'd have to subtract 3 from each side, so you've got y equals negative 4/3 x, and then negative 16/3 minus 9/3 is minus 25/3, which is 8 1/3. So these would be the two asymptotes. So basically, I'm going to draw this with a computer. It'll just be, oh, I'm sorry, but it's going to look something like this, whatever. And the asymptotes are going to look something like this. They're all going to cross through here, and they're going to look like this. So what I'm going to do is, rather than use my free hand, I'll graph it, and I'll show you what it looks like on the computer. Okay, so this is what the hyperbola would look like. Notice our center was negative 4, negative 3. The vertices were 3 away in each direction, 1, 2, 3, and 1, 2, 3. And the asymptotes would go something like this. One would go from here all the way down here, just never actually hitting the line, and the other would go down in the other direction.